Alright guys, what we're going to be learning is how to solve exponential equations using the property of exponents. So I want you guys right now in your journal, if you would please, I want you guys to write something down for me, okay? See if you guys get this pattern. 2 to the power of x equals 2 to the power of 5. What do you guys think x would have to be in order for these to be equal? 5, you're right. Very good. Okay, let's change the base now. Ready? What if I had 1/2 to the power of x equals 1/2 to the power of, let's say, 7? What do you guys think x would have to equal 7? Yeah. All right. So basically, the only way this works is we have to have what's called the same base. You see these bases are the same? Let's do another one. If I say 7 to the power of x equals 7 to the power of happy face, what do you think x would have to equal? You're right, happy face. That's not a very good happy face. There we go. There we go. Now, like I said, what has to match these bases have to what? Have to match in order for you to be able to solve for x. So every single one of these, in order to solve for x, when I say solve for x, these now would be equal to each other. These would be equal to each other, and these would be equal to each other. So if we go back to our problem, all right, let's go back over to our problem right here. Sorry about that. I'm going to write a little bit bigger. It says 64 to the power of 7x minus 8 equals the number 1. Are these bases equal? No, they're not, are they? Okay. So we got to know a little bit about the properties of exponents. All right. So here's what you need to understand. 64 raised to the power of 1, 64 raised to the power of 2 means 64 times 64. But not very many people in the world right now, if they were interviewed, if they weren't having a math class, they wouldn't know what 64 to the power of 0 is if you just asked them off the top of their heads. 64 to the power of 0 is equal to 1. 64 to the power of negative 1 is actually 1 over 64. And 64 to the power of negative 2 would actually equal 1 over 64 squared. And that's how it keeps going. All right. So right now, what I'd like you to do in your journal is I want you to erase, actually not erase, just change the base. Ready? Change it from a 1 and rewrite it as 64 to the power of 0. Now what do we have? We have what's called the same base. Once these bases are the same, then and only then are you allowed to set this expression equal to this. So what am I going to set equal to each other, everybody? What does 7x minus 8 have to equal? That's right, it's equal to 0. So at this point, we have to go back to our Algebra 1 knowledge of solving for x. So how do we solve for x? It's very, very easy. We just get all the x's on one side and all the numbers on the other side. So we're left with 7x equals 8. Divide both sides by 7, and x equals 8 over 7. So what's my answer going to be for this particular problem? 8 over 7. That'll be my answer. That's what x has to be in order for 64 to this power to equal a 1. So I'll go over here, I'll type in an 8 divided by 7. Now, understand that's not going to be enough. We need to do more than just one problem for you to be able to get this. So we're going to do 3 more. All right? It's going to be super fast. It's not going to be hard at all. We have 5 raised to the power of 7x plus 5 equals 125 to the power of 2x minus 7. That's the first thing I want you to do is just simply write it out. What base do you think we're going to probably want to change everything to? A 5 or a base of 125? What do you think seems more simple? 5. Very good. So you got to kind of know your 5s. Now, it's not that hard if you don't know your 5s. Everybody knows 5 to the power of 1 is 5. Well, hopefully everybody. And hopefully everybody knows 5 squared is 25. Well, just so you guys know, 5 cubed is actually 125. So what I want you to do is take this guy, and could you convert him to 5 cubed? I've not changed the value of the number. I've simply changed the way the number looks from 125 to 5 cubed. Now, what do I bring down? What do you think I bring down right here? That 2x minus 7. And I just bring down my original expression over here. There we go. Does everybody see now? We have the same what? Same base. What are we working in? Base 5. Now, this is the part where students will make a mistake. This right here, they will forget is what's called the power property, and what we actually have to do is we actually have to multiply these two powers together. So anybody want to know what 3 times 2x and 3 times negative 7 is? 3 times 2x is 6x. 3 times negative 7 is negative 21. And we're going to set that equal to this. So hopefully you'll understand. I don't need to worry about these 5s anymore because I've changed them to the same base. All I got to do is now just solve for x. So what would I do to solve for x right here? I would take away 6x from this side and 6x from this side. I'm left with x. I'd have to take away 5 from this side, take away 5 from this side, and I'm left with negative 26. So in this particular problem, what does x end up becoming? Negative 26. And that's what I'm going to type in right here. All right, so let's do a quick little review. Right now, these bases weren't the same. So what was step 1? To take that 125 and change it to what? 5 cubed. Then I used the power property and multiplied 3 times the 2x and 3 times the negative 7 to get the 6x minus 21. And then I solved for x and got x equals negative 26. All right. All right, here we go. Next problem. It's very, very easy. All you guys got to do is just write it down and see if you can follow the pattern and make the connections. So I got 1 over 64. And that's, I don't know if you can see it, but that's a negative. I'm putting negative 2/3. So go and write it. 8 to the power of 5x plus 3 equals 1 over 64 raised to the power of negative 2/3. Are these the same base? They are not, are they? All right, so here we go. In your journal, 8 to the power of 1 is 8. 8 to the power of 2 is 64. 8 to the power of 0 is 1. So I'm going to just go to the side here. What do you guys think 8 to the power of negative 1 is? That's 1 over 8. What about 8 to the power of negative 2? 1 over 64. So this is what we're going to use, guys. We're going to use this. These are equivalent to each other. So what am I going to convert 1 over 64 and actually put in my parentheses this time? 8 to the power of negative 2. Now what's sitting already out here already? So make sure you bring it down. Bring down that negative 2/3, all right? Okay. Once you write that down, what you need to do is just stop and take a look at what you have. Do we see we have the same base? Now that these match, what can I set equal to each other? I can set this equal to whatever this is. But what property do we have to use with these powers? We have to use the power property, right? And what does that allow us to do? Multiply those together. So we know we have what? 5x plus 3. But what's a negative 2 times a negative 2/3? A negative times a negative is a positive, and that leaves me with what's called 4/3. All right. So now we just got to solve for x, and we're done. So what would we have to take away from both sides? Have to take away a 3. Have to take away a 3. Okay. So this zeroes out. We're left with 5x equals whatever 4/3 minus 3 is. So just take your calculator and do 4/3 minus 3. Hit the math button. Press enter twice. What do you get? Negative 5/3. So just put negative 5/3. Now some of you will probably be tempted to divide both sides by 5, and that's fine. You can divide both sides by 5. I'm simply going to multiply both sides by 1/5. Now why am I multiplying both sides by 1/5? Because I know a 5th cancels out a 5, and I'm just left with x. And then you can see if I did it the long way, this would be negative 5 over 15, but these 5's cancel out, and you're left with negative 1/3. Now, that's going to be my answer, okay? I don't know, it's just pouring down rain right now outside. All right, so in the calculator, if you did take negative 5 divided by 3, and then you ended up dividing it by 5, you could still get the same answer as negative 1/3. All right? Negative 1/3. All right, I'm just going to do one more problem. Okay? Do one more problem, and then I'll let you guys kind of work on your own. So if you would, please. By the way, a lot of my students have gotten these exact problems, so you might get one of these when you're working on your assignment, and you'll already have one done. So that's why I like doing these example problems, is I like to have problems where you might actually get one of them. Then you guys have less to do. So what base do you think I'd probably need to change everything to? What do you think? What seems to be the easiest base? A base 3 or a base 1/27? I don't know. Which one do you think is easier? Base 3. All right, so we just need to know our 3's. So if you would, please, do 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. Just so you know, 3 to the power of 0 is still 1. Anybody want to take a guess what 3 to the power of negative 1 is? I have no volunteers. Nobody wants to risk it. What is it? You're right, 1/3. Very good. What about 3 to the power of negative 2? 1/9. No way. 3 to the power of negative 3? No way. It's 1/27. Why am I excited? Because you're a geek. Yes, I'm a geek, but I don't care. But right here, see that 1/27? What is that equivalent to? 3 to the power of? So change it. 3 to the power of negative 3. Now what's already sitting out there? An x minus 3. So if you would please, put a little parentheses around that. Little parentheses, they matter. All right, now, does everybody now see that I have the same base? If I have the same base, then I'm allowed to take this expression and set it equal to this expression. So that's what I want you to do in your journals right now. I want you to take the 7x plus 4 and set it equal to negative 3, parentheses, x minus 3, close parentheses. So what are we going to have to do? Distribute the what? Distribute that negative 3. So it becomes negative 3x plus 9, and this stays 7x plus 4. Now I have a lot of students ask me, they're like, well, how do you know where to put the x's? Now, you could put all the x's on the left, you can put all the x's on the right, I like to put the x's where there's the most positive x's, or the most. So over here, to see how there's 7 over here? So I just move everything over to the left. If there were more x's on the right, then I'd move everything on the right. But right now, I got to get rid of negative 3x, so I got to add 3x. I got to add 3x, which gets me a total of 10x. Then I got to take away 4, and then I got to take away 4, and that gives me a 5. So right now, what's everything equal to? Just a 5. And I got one step. What's my last step? Divide both sides by 10. Now, technically, yes, 5 over 10 is right, but we got to reduce it. Why did I not reduce the others? Because they were already simplified. So what am I going to put in this guy? 1 over 2. All right? It's 1 over 2. Now, I want you to see something real quick. Maybe you guys can use the calculator to help yourselves out. What did we say x was equal to? 1 over 2. So watch this. If I say 3 to the power of 7 times 1 divided by 2, close parentheses, plus 4, does everybody see what that decimal equivalent is equal to? And then if I go back to the problem and say parentheses 1 divided by 27, close parentheses, to the power of what, x minus 3? We said x was 1/2, so I'll do 1/2 minus 3 and press enter. What does that tell you about our problem? What answer did we get? We got what? 1/2, and these are exactly equal to each other. So when I got my answer, I plugged it in, and that's how, if you really wanted to make sure, like you're like, oh, I don't know if my answer's right, plug it in, and if this side equals this side, that means you got the answer right. Does everybody understand? I took x and I plugged it in there, and I plugged it in there, and they end up becoming equal to each other. So you literally, every single problem, if you really wanted to, you could check your answers by doing what? Plugging your answers in and seeing if one side is equal to the other. And that's all you got to do. All right? So, by the way, you guys can start working. You don't have to pay attention to my class, to me anymore. Just work. What base do you guys think? I'm doing one more just for the people who are watching. What base? Yeah, to the power of 2, right? So instead of 7, it's going to be 7 squared. So I'm going to put right here, sorry, it's supposed to be a 1, equals, so instead of a 49, what am I going to put in parentheses? 7 squared, but what's already sitting out there? Negative 12. So what do I got to do? Power to a power. And I got to set this equal to each other. So I got what? Negative 9x plus 1 equals negative 24. Where the heck did I get negative 24? Because 2 times negative 12 is negative 24. Then take away 1, take away 1. You get negative 25, and divide both sides by negative 9. And your answer is 25 over 9, because the negatives cancel out. So what am I going to put right here? 25 over 9. So here we go. 2 steps. Ready? Change to the same what? The same base. Step 1. Step 2. Solve for x. That's it. Change the same base. Solve for s. Not s. X. And what property did you see me use a lot? Remember to use the power property, which is power to a power. And that's when you take the exponents and you do what? You multiply them together. All right? So I'll go ahead and type in 25 over 9, and that'll be the end of the video. And that's how you get 100. Good luck.